Hello everyone, good evening. Welcome to the day 3 of Android Study Jam sessions. Today we are going to have the last session of Android Study Jams. So the agenda for today is we are going to build a dice roller app and we'll be adding sensor inputs to that app. So without wasting any time, I would like to hand it over to Karthik to take the session forward. Karthik, over to you.
So, hello everyone. Thank you, Monica. Welcome to the third and last day of the Android Study Jam sessions. Today, as Monica said, we will be building a dice roller app and adding sensor inputs to it. So, um, the traditional way of throwing dice is you shake the dice in your hand and then let it fall. So we want to mimic that. We want to mimic that experience with the app. So we are going to add sensor inputs. So when we shake the device, it will trigger the dice roll. So before the session, I would like to thank you all for coming, and I will looking forward to your comments and your questions at the end. So without further ado, let us start. Um, Now, let me share my screen and I'll show you what we'll be using as a template. So there are Google has some guided lessons called collabs that teach you that are a step-by-step guide to building an app on Android. So we'll be using for the framework for the base, we'll be using this collab called Create an Interactive Dice Roller App. You will find the link to this in the event description. Um, the You can follow along and then continue from where I am starting right now, or you can simply download the solution code. The steps for setting up the code in your Android Studio instance is are detailed here. You can follow this. You can either follow all the 7 steps and you will come to this point, or you can download this code directly and start from where I'm starting right now. So this is the code that we'll be cloning, that I've already cloned, that we'll be modifying today. This code is on GitHub. Again, it is open source. You can take a look at the code. And this is just so that we don't spend a lot of time setting up the app. So now that we are clear of the setup, um, if anyone has any questions, please feel free to interrupt me. I will be happy to answer them. I will be also pausing after each section. So if you have any questions, you can ask them then. I will go ahead and share my Android Studio instance. Um, Now, whenever you get an app, whenever you get a code base, if you have to ever work with an existing code base, my suggestion is you first run the code, build the code, and try to run it as it is without any modifications, um, just to ensure that the code itself is working properly, and any errors that you find, any warnings that you find, are not because of you. They were there before. You might need to fix them before moving on, but that way you're not confused whether the error is because of you, because of your modifications, or because it was there previously. So this is what you would see when you open the app in Android Studio after cloning it. There are no modifications to this. Let us run the app. So as covered yesterday, you click this button, which will automatically run the app in the Android emulator. Um, and Meanwhile, while the app is building, it will take some time to build. If someone would like to share their experience, share if you have worked with Android Studio previously, or maybe you have um, worked with um, an Android app previously, you are please feel free to do so. Any suggestions, any comments are welcome. So you will notice in the meanwhile that the app is now installing. You can see the status right here, and this is the Android emulator. This is the um, virtual Android device that uh, on which the app can be tested without actually having a physical device. We went over the benefits and the disadvantages of a virtual device compared to a physical device in the first session, so you can refer back to that if you want a refresher. But right now, let us just check that the app is working. If you click on roll, you will notice that it does show a random number each time, and the number is between 1 and 6, just like a real dice. So now that we have confirmed, we have verified that the app is working correctly without our modifications, we can now start modifying the app. So the first step would be to exit the app, and then now this is the main activity. I won't be going into detail of about the structure of the project or how uh, you should structure a project. This is just for demonstration purposes, just to I might be breaking some best practices, but this is just again to demonstrate the what you can do in Android. The first thing we want to do is create um, define some global constants. We want to define some constants for the class. So the way to do that in Kotlin. Now, those of you familiar with Java will be knowing that there is something called private, static, final, and then you type in a variable name. For example, shake threshold. Now the this does not work in Kotlin because all first of all static is not a valid modifier, and also all class properties must be either mutable or they must be inside an object. So the way to do the way to define global like class wide static properties is with a companion object. So you do companion object, it'll auto complete for you, and then you open curly braces. Then you type in private const, which is final in Kotlin, val for read only value, um, shake threshold is equal to 1.15 f. Now the reason that we are defining these thresholds is so that we there's only one source of truth. We do not need to find, if suppose we need to if we have to change the threshold, we don't need to go over the search the code for every instance of the threshold. We can change it in one place. Now let us break this declaration down. So this is saying that we want to declare a private variable. A private variable means it cannot be accessed outside this class. We want it to be const, which means that the value should not change during execution. This is a value, so val. This is the name of the variable. So shake threshold is the name of the variable, and we are setting it equal to 1.15. The f here is important because this signifies that this is a floating point value as opposed to a double value. Now, float and double are two different types of representation. I won't get into detail right now, but for now, just remember that this is to denote the f here forces this to be a float. By default, all floating point values are doubles. Then we will also need one more uh, static property, one more value called shake delay. Let us say, and it is a good practice to specify the unit as well, because it is otherwise it can be ambiguous. Is it in seconds? Is it milliseconds? So let me specify this in milliseconds, and let us call it maybe 500 milliseconds is good. So I'm setting up these properties to use later on in the code. Now, what is shake threshold? The way that Android measures acceleration, the way that your device will measure this, if you're shaking your phone, is by using a sensor called an accelerometer. Um, and that device measures the gravitational forces, the change in gravitational force experienced by the device as you move it. So one, if I set this to one, if the shake threshold is one, that signifies standard Earth gravity, which will always be present. So whenever you use your phone, whenever the phone is kept on a table or it is in your hand, it is always experiencing the standard gravitational pull of the earth. But when you start shaking the phone, if you start moving the phone, then it will read additional values, the force on it increases, and the threshold that we have specified is it should increase 0.15 0.15 times the standard gravitational force. So if the force exceeds this threshold, if the acceleration exceeds this threshold, then we will trigger it. We will detect it as a shake. We'll detect the value as a shake. Now, let us also declare some non-static fields. These will be initialized uh, when the uh, class is loaded, when the app is run. The difference between so let me first declare these fields. So let me do private var, so variable uh, sensor manager. So let us have one sensor manager and sensor manager, and let us make it nullable. I'll go over these details in just a second. So private variable accelerometer and let us make that a sensor and make it nullable as well. And finally, private variable shake detector, which will be a sensor event listener, which is also nullable and set to null. Now, let me go over the meanings of these definitions just now. Um, So private, again, we went over this. This means the variable cannot be accessed outside the class. Bar stands for variable, which means it can be reassigned later on. Sensor manager is the name of the variable. Then here, this is the type of the variable, which is again sensor manager. And the question mark indicates that the variable can hold the value of null. Now, Kotlin has this concept of null safety, wherein unless you specifically mark a variable that is nullable, unless you mark it to be nullable, you cannot assign a value to null. So if I remove this question mark, you will notice there's a syntax error, which says a null cannot be a value of non-null type, which means that since I've told the compiler that this variable can never be null, I cannot assign a null value to it. Now, null safety is something that Java struggles with a lot. This is one of the benefits of Kotlin, that you have increased null safety. This does not mean that you will never have null pointer exceptions. This does not mean that you will never have issues with null values, but it does mean that they will be very easy to catch when they do happen, and they will definitely happen less frequently. So this is not a silver bullet. This is not a magic thing, something magical that will save you from null pointer exceptions, but this is definitely something that can help. Now, coming back, uh, the final variable we'll need to declare is a last shaken timestamp. So now the reason is that um, the reason for declaring this is, let us say you are continuously shaking your phone for maybe 1 second. In during that time, since we specified a delay, we want shakes to be registered after every 500 milliseconds. So there are 1000 milliseconds in 1 second. So the shake event should trigger twice. But the way callbacks work in Android, the way the sensor listener is set up, you need a previous point of reference. You need the last point of reference to know when exactly the callback was triggered, to calculate the difference. So this is for that. Now, um, you will see we can remove these comments. We can condense the code a little bit. Um, this is so by reading the code, you can see that the roll button, which is the button we clicked that says roll, is calling this roll dice method whenever the it is clicked. So on click, it is calling the roll dice function, and we want to call the roll dice function whenever the phone is shaken. Now, to do that, first we need to know when the phone is shaken. And we need to register some sensor listeners. So uh, we first need to, so on the onCreate method is called once when the activity is created, as described in this comment. This method is called when the activity is created. And let us, this method will run, it is supposed to initialize all the resources that the app needs during its runtime. So all the resources that the app will access, they should be set up in onCreate. And remember these null references we created. We cannot use these null references because they do not point to anything. They are null references. So we need to initialize them in the onCreate method. The way to do that is, so this is a lot of syntax. The best way to uh, do these such kind of syntax heavy things is refer to the documentation. Um, they have good Android has very good documentation, especially the Kotlin part, and you can get usually you can find very good examples. This is straight from that. This is straight from one of the examples from of setting up sensor manager, a sensor listener, and the sensor type. How do you get a particular sensor for a device? So let me type that out right here, and let me go over this in detail again. So what we are doing here is setting a sensor manager. We are assigning the value to a the variable we declared earlier, the sensor manager variable. We are assigning it the value of get system service. So we are calling this method called get system service, which is sorry, sensor service. It should be sensor service. Um, and we are getting the sensor service, which is responsible for managing. It is supposed to be the interface with which your app communicates with the hardware about the all the present sensors. And as is typecasting it to a sensor manager by default, the return type of get system service is object. It is a generic type of object. We are typecasting it as sensor manager for again to increase type safety. Then accelerometer, we are getting the value of sensor manager. Now notice this double exclamation mark. These two, it is called a bang bang double bang operator. Um, and what this does is it forces this to be not null. So if you remember, if I remove this double bang symbol, you will notice there's a syntax error. The compiler is not happy. This is because sensor manager can be null. Sensor manager, if you remember, we declared it as a nullable type and we did set the value to null. So we don't want that. So if for whatever reason this get system service method fails, if for any reason it returns a null, which means it did not complete properly, then we want the app to throw a null pointer exception so that it does not continue in a corrupted state. Now, Kotlin also has the optional chaining operator. The optional chaining operator will default to null if any of the preceding arguments are null. What that means is if sensor manager itself is null, then this entire line will not execute. This will not, and quietly set this to null. Now, that is useful in some cases where you do not want to perform the action if the variable is null. So if sensor manager is null, you want to skip this, then this is fine. But since this is important, this is integral to the functioning of our app, and we want to be notified that there's an error if this does not complete properly, then the best course of action, the recommended course of action, is to enforce it to not be null, which is done with the double bang operator. Now, the next thing we need to do is initialize our shake detector variable, this shake detector variable. And now, those of you familiar with Java will maybe know about anonymous classes and anonymous interfaces. Anonymous classes are a way to create, instead of extending the, instead of having your whole class extend the interface and then having multiple overloaded methods, you can simply create an anonymous class for each one, each instance, and then the VM, the virtual machine, is responsible for taking care of how to structure the objects. Um, the way to do that in Kotlin is you have to use the object keyword, object, then the class type, in this case is sensor uh, event listener. This is the name of the class. Then we will need to override these functions. And the way to do that is using the override keyword, override function on sensor change. You'll notice that it'll auto complete for me. I'll go ahead and do that. Um, Rename this to event, and you will notice that the type of event is sensor event, and the question mark again means it is nullable. So we need to take care that this is whatever event we pass on, we need to take care that it might be null. This is something we need to keep in mind. Um, the next thing we this also has two methods. So whenever you override an interface, you must override all methods. You cannot skip out on a method. So let us override the second method. Let us also rename the uh, arguments so that they make more sense. So the sensor, this is the event, this is the sensor, and let us say this is the accuracy. Now, we won't be using the on accuracy change method in this today. We won't be using it in this app. So we can simply go ahead and uh, mark it, close the method because we won't be implementing it. Um, Now, this function, this on sensor change event, this is what we're interested in. We will need to implement this event. So for now, let us not let us leave the to do comment as it is. So this is a comment. This is a to do comment. If you actually run this app, the to do function is a special function. It will throw an exception with the reason. So if in case you forget something, if in case you forget to implement this method, the app will remind you that you have not implemented it yet. Now, before we move on further, before we move on to actually handling the shake event logic and the subsequent calling of the functions, I would like to pause right here and just revise what we have gone over. So we went over the main activity. We went over how to create global constants. Why would you want to create global constants as opposed to hard coding the values in the app? We went over the Kotlin syntax for nullable variables, nullable values. Like why do we need to mark some variables nullable, and why do we need the private modifier? Why do we need the question mark at the end? Um, and then finally, we also went over the double bang operator, the reason for using the double bang operator as opposed to the optional chaining operator, which is question mark, and how to create an anonymous interface, how to create an anonymous class in Kotlin. If anyone has any questions at this point, again, I'll be happy to take them right now. Um, Otherwise, we can move on.
Why are we not using late keyword to initialize the variables?
Late init. So
Yeah.
late init is more useful for heavy resources that you will need in the background. Now, sensor manager, these sensors need to be initialized before the app can start. We need them to be working as soon as the app opens. Otherwise, we have undefined behavior. What happens if the user shakes the phone and the sensor is not initialized? It will create this is not good for your user experience because the user has no way of telling whether the app is ready or not. Now, if this was a very resource intensive operation, if would take maybe 30 seconds or 20 seconds to initialize, then we could use latenet. But then we will have to, the best practice is to show some kind of loading indicator to the user to indicate that the app is still starting up, and the user has to wait. But again, since this is a very, very fast operation, we usually won't need to wait more than a couple of milliseconds for these function calls to finish. We are not using latency right now. Does that answer your question, uh, Darshan? Right? Yes. Does that answer your question?
But we can still use it na, to initialize the variable later. Like
Yeah.
we won't require any null checks or something like that.
Yes, but that will make it a little more complicated. I don't want to um, I don't want to bring in that additional complexity right now. And also, this is not a constructor. This is a method on create. So the Kotlin framework does not provide support for late init in a method because you cannot guarantee that the method will be called before the constructor. So that is why in this session, I do not want to get into complexity and the nuances and the pitfalls of using late init. So I won't be covering that right now. I'll be happy to share some resources later on if you are interested in learning more. But for today, we will be going the simple way. We will be having a very simple implementation with using null checks. This can be improved definitely, but let us keep it simple for the beginners. Okay.
Yep. Thanks.
Okay. So if anyone else has any questions, no? Okay then. So we'll move on. Now we need to do something about this event listener, about this sensor event. So let us create a new function, again a private function, called, let us say, handle shake event. It's not a shake event, but handle sensor event, and the event sensor event. Again, remember the question mark, because this will be passing a potential null operator inside. So we need to take care of that. We need to ensure that it is not null. Now, uh, now one more thing to take care is, if we do that, so let us continue and come back to this later on. So now we need to extract the x, y, and z um, values of acceleration from the sensor event. So the way to do that is using event dot values. So this is an array. It's an array of length 3, which contains the x, y, and z coordinates of the acceleration change respectively. So the accelerometer can only measure changes in acceleration. It can only measure when the phone is being accelerated. So this event contains those values. So let us have event.values of 0. This is for the x. Then we do the same for y and z. Now, now that we have extracted these values, you will notice that the compiler is again not happy, because we have mark the sensor event as null. Now this is we need to do that, or we can also mark this as not null. We can say that this will never be null, and perform the null check here. The benefit is that we won't have to write the entire function using null checks. We won't have to use either bang bang or the optional chaining operator in this context in every single case, and that way we are saved the extra visual noise. We can also do something like uh, const var not null event is equal to event bang bang, which will make it so that we can use a not null event, and if there is any issue, the first line will throw an exception. But that is also another use case, but then the delays. So the one of the reasons that null pointer exceptions are so hard to debug is that the actual exception might occur very far away from the place where the null assignment happened. What that means is, let us say there's a null pointer exception here. The Now, why this null pointer exception occurs is because the event variable is null. Why is this null? Is because the caller passed it. Whoever called this function passed it null. Now, who is the calling function? In this case, it will be on sensor changed. We will do that later. We'll put the implementation later. But in this case, it will be on sensor changed. But we then need to find the reason that why did on sensor change received a null value. So the further removed your null pointer exception is from the actual place of null assignment, wherever the null value was created. The further you are from that, the more difficult it is to debug. So that is why it is preferable. It is preferred to keep null checks as far away from your actual logic as possible, and only have them in the beginning, not in every function. Now, if this were a public function, if this were allowed to be called from outside the class, then it would be better to perform null checks here inside the function, because you don't have control of the caller, of who calls this function if it is public. But since it is private, we know that all the callers will be inside the class itself. No one can call it from outside the class. We can perform the null check in on sensor changed, and again save us some logic in and visual noise in this function. Now that we have extracted these values, we will need to normalize them. Again, as you remember, I mentioned that your phone will always experience the standard gravitational force of the Earth, that is 9.8 meter per second squared of gravity. And you will notice that These are some inbuilt values for Android. Now, Gravity Death Star 1 is a reference to Star Wars. It is actually an Easter egg. Death Star 1 being the fleet, the Imperial ship, the large Imperial ship. But you also have more practical measurements, that is for Earth, Jupiter, Mars. You mostly, again, will use Earth. In this case, since we are on Earth, we will use the standard gravitational force on Earth, which is 9.81 meter per second square. As you can see, 81 meters per second square. And we will normalize these values because we want them relative to Earth's acceleration. So we'll normalize all three values. And now that we have the normalized values, you will note that they can be positive or negative. Since the phone can move in either direction, the gravitational force can be, the acceleration can be either positive or negative in both directions. So we will calculate the total deviation, the total g-force, as it is called, using the standard Pythagorean formula for distance in 3 dimensions, which is, let's just declare the variable. So g-force is equal to, let us say, the gx into gx. So x square plus gy into gy plus gz into gz. Now, I like to club these values together so that it is easier to read. And this is the standard formula, and you will need to take the square root of that. So sqrt of that. And this is a standard formula for the Pythagorean distance formula for finding the distance between three coordinates in three-dimensional space. So this is again the standard formula for also finding the total force for this kind of event. When you have three values in three different dimensions, this also works to find the total force. Now we can use this. We can use this as is, but again, I'll come back to this later. Why we might want to change that. Now the next thing is we have an if check. We check if our g-force is greater than the shake threshold. If it is greater than the threshold of gravity we set, then we want to reset. We want to first capture a variable called now. We want the current system time as a timestamp. Now, I won't go into these Unix epoch or the timestamp metric. Again, I'll be sharing some resources at the end if you are interested in that, in timekeeping and how computers measure time. But for now, I won't get into the epoch. And just know that this is a constantly incrementing value. It's always increase. So if two values are greater, then that means those times come later. So if the last second timestamp, so if now minus the last second timestamp, that is the difference in milliseconds. The difference in milliseconds between the shakes, between the two events, is greater than or equal to our threshold, so shake threshold. Then we know, sorry, this is the I think shake delay. If it is greater than shake delay, then we know that we need to fire another event, that the last event was more than 500 milliseconds ago, and we need to fire another event. And to fire an event, what the first thing we want to do is again reset the last second timestamp to now. This is just so that the next time it works properly. And finally, we want to perform our event. We want to perform the action, which is roll time. So all this logic, all this function does is it receives a sensor event. It receives a non-null sensor event, guaranteed to not be null. It will extract the acceleration in the x direction, in the y direction, and the z direction into three separate values. It will normalize those values with respect to the Earth's gravity, so that we do not count the Earth's gravity twice. And then it will find total gravitational force, g force, on the phone at that instant. And if it is greater than the threshold we defined earlier, it will perform some time check. So that this is called debouncing an event. So that way your events don't occur too close to each other. If the user is shaking the phone very vigorously, you won't want the events to occur very close to each other. This is called debouncing, and it debounces the event. And finally, after debouncing, it will call the function that we want to call once. Now that all of this is done, the I will get into the optimization I mentioned earlier. So taking the square root of a number is a very expensive operation. It is not computationally simple. It takes a lot of time. There are different implementations. Usually, you don't have to worry about it. Usually, um, you know, you don't worry about the square root. It is fast enough for one number. But since we will potentially be doing this many times a second, since this is going to be very quick, we do not want to um, do it too often. Like, we do not want to. We want the app to be responsive as possible. So a simple trick is, it is used a lot in game development, especially, is instead of using the square root, instead of taking the square root of a number, since both numbers are guaranteed to be positive, g-force will be positive since all these are positive, and shake threshold is positive because we define it to be positive. We can simply square both sides of the equation. We can square g-force and square the shake threshold, and that way we don't have to do a very time consuming square root operation. So let me change this to g-force square and square this threshold value. So I'll multiply this with itself and square the threshold value. And the reason we are doing this, the reason we are not using square root here, is again because square root is an expensive operation. It takes some time for the system to compute the square root. Whereas multiplication, addition are very fast operations. They are usually implemented in the processor level itself. Whereas square root, you need a custom routine. You need a separate. That is also very fast, but not as fast as multiplying and adding. So this is another slight optimization that we can do to improve the runtime of our app, the speed of our app. Now, again, I would like to pause here. I'd like to recap. We just created a function called handle shake event that will take an event, and it will check if it exceeds the threshold. It will check if the shake event should be fired, if the phone is being shaken, and debounce the event. So it will not fire it very close to each other. It will not fire it continuously. And finally, if everything is fine, it will fire the actual event. It will perform the action we want to perform. Now, I hope everyone is clear at this point. If anyone again has any questions, has any doubts, I would be happy to answer them right now. Okay, so moving on, the last part that is left is we need to actually call this. We need to call the handle shake event from our event listener. And since the event will be null, it might be null, we will need to force it to not be null. Again, we're using null pointer. We are using the double bang operator to throw a null pointer exception. So again, this ties into the principle of being as close to the source of the null value generation as possible. So that way you don't. It is easier to debug in the future. If errors do occur, they are easier to debug in the future. Now, one last thing. After doing all this setup, we actually need to register the event listener. We need to tell the sensor manager. We need to register this event listener shake detector with our sensor manager. And the way to do that is, again, we need to dereference it. We need to force it to not be null and register listener. And this takes in three arguments. This takes in um, three arguments. One is the first is the actual listener, the event listener. The second is the sensor, which we want to track, which is accelerometer in this case. We want to track the accelerometer in this case. And the third is the sensor delay. Now, the accuracy of the sensor has a default accuracy by inbuilt to it, but it also matters how often you are calling the sensor. Now, the way for the Android system to get the value of the sensor is to ask it for its value, and that consumes power. It takes time. So if your app does not need a very accurate value, for example, you are building something like this where the exact value does not matter. We just want if the value is changing above or below a threshold, then you can use the lowest sensor delay, which is sensor manager sensor delay UI. This is this is not slow. This is a decent mix between um, the delay between performance and responsiveness. So if the delay is too long, then the user will experience a lag in shaking the phone and seeing the action, which is not good for experience. If it is too high, then the system will be forced to perform too many updates, which is resource intensive, and it is also slow. Sometimes it can cause the app to slow down, which is also not good for user experience. So a good rule of thumb is to only use the minimum delay you can get away with. You can use the slowest setting that works with your app. If your app is a game, if you're building a game like say Temple Run, where you need to tilt the phone, you need immediate response, immediate feedback from the user. When the phone is tilted, you should use something like game sensor delay game, which is again especially for games. And maybe this is too slow for you. Maybe your game relies a lot on the sensor, on the accelerometer, on the sensor in question, in which case you can also do fastest. So sensor delay fastest, which means it will this is instructing the system to give you the most accurate information possible as soon as possible. But again, this will cause a strain on system resources. That is why the best, again, the rule of thumb is to use the slowest setting with which your app works. In this case, it is sensor delay UI. You can choose something else depending on your use case. Now, with that, I think we are finished with the actual modifications that are needed to run the app. We can see that there is no red underline, which means there are no compile errors. There are no issues with the code. So we can go ahead and build this. We can run app on the emulator. We can run the app, and once the app runs, you can monitor the progress from here. This will tell you how far it has got. So once the app runs, we can test it out on the emulator using virtual sensors. Now, again, the benefit of using an emulator is that you can emulate any sensor you want. So this is asking me, since we already had the app running before, it is asking if you want to terminate the old process. Yes, we do want to terminate the old process. That is no longer needed. Um, and now that the app is built, yes, this is informing me that the app has successfully been built, and it is launched on the emulator. Now you can see that it does not look any different. The roll command still seems to be working the same. But if I let me open the emulator emulation section. The control panel where with which I can change the sensor values. So since the emulator is a virtual device, you cannot actually hold it and shake it. You need to any sensor inputs, you need to give it to the command panel, the extended control section, and you will see that this has this list of all the different inputs that an Android device can have. So you have multiple displays. You can change cellular. You can show. You can save a camera. Now the part we are interested in right now is virtual sensors. So virtual sensors, you can see that it will give me. It shows me the values right now, what the values are reading. Here, as I mentioned before, this is in the y direction. This is x, y, z. In the y direction, the sensor is reading the standard Earth gravitational potential of 9.81 meter per second square, which the phone will experience at all times while it is on Earth. We can rotate the phone. We can rotate the phone and cause a shift in the gyroscope and accelerometer readings. Or we can also reset the rotation like this. If you want, you can grab the phone directly and rotate in 3D space, which is especially useful for if you want to get a particular orientation. It is difficult with these sliders. And let's reset the orientation again. And for move, again, we can move the phone with the mouse, which is also called a shake event. We can also use these sliders. Now you will notice that when I shake the phone, uh, it should cause the value to change. So let's try this again. And you can see that the value did change. The value was 1. Now, since I shook the phone, it changed to 3. It randomized to 3, and that is what we wanted to achieve. So again, to recap, what we did was we cloned the app. We cloned a pre-existing app from GitHub, from Google's repository. We opened it in Android Studio. We modified the code to include this feature to make it read from the accelerometer, to make it read the um, G-force that is the phone is experiencing. And as long as if the G-force exceeds a certain amount, if it exceeds a certain threshold, the app will trigger an action, which in this case is to roll a dice. Let us try this one more time, and you will see that that is the debouncing. So we might need to adjust the debouncing value to slightly more, because you saw the value change twice. Now, the point of debouncing is to prevent that. So you might need to play with some values to get it to work properly, but this is the core example. Now, at this point, the session is over. This is what we wanted to do today. Um, Now, as an additional part of the session, after the session completes, you can extend this app further by maybe adding a dice rolling animation. You can have an animation that rolls the dice. You might need to use a GIF or SVG for that. You can also extend the app by having a reactive dice. So you can have maybe one or two dice in this circle. You can maybe have a circle here, have one dice, and when you tilt the device, when you say tilt the device like this, the dice also tilts. The dice falls. You have a small physics simulation. So that is something you can play with. You can also have options. You can add settings for the number of dice, the number of sides of dice, and the total number of dice that you roll at one time. So maybe you want to roll three six-sided dice. You want to roll two 20-sided die. That is also something you can do. But I just wanted to provide a framework for this. The complete code with comments, I'll add some comments to explain what is going on. The complete code with comments will be available on my GitLab repository. I will make the link available again after the session completes. So you feel free to go ahead and modify it as you see fit. But for now, that concludes the session for today. If anyone has any questions, if anyone has any doubts, I'll be happy to answer them right now. Um, okay, so thank you all for coming. Thank you all for attending the session. The